Alright, so today's lesson is union, intersections, and Venn diagrams. We're going to go over the basics of this right now. In class, we'll go over more complicated problems, alright? So take notes and please pay attention. Alright, so Venn diagrams, we're going to be looking at two variables in this section for the most part, and then we're going to go switch into three variables, which we'll probably do in class, alright? Before we do that, we're always going to use the universal set, and what that is basically a huge or a capital U containing all the elements in these two sets. All right, so everything in here in this box is under the universal set. All right, the first one we're going to look at is the intersection. So A intersect B. All right, and that's this symbol right there. All right, A intersects B means that if we were to look at the diagram, it's where A and B intersect, and this is the region we're looking at or we're concentrating on. All right, A intersection B is just the middle part right here. All right, the second part is the union. So A union B. All right, what that is if we have two sets right here, A union B would be everything in A and everything in B. All right, so we're looking at everything in between these two circles. The next is A naught. All right, this is basically everything that's outside of A. So if we have A right here, this is our A circle. A naught would be everything outside the A circle. So we're looking at all these shaded regions in the universal set. All right, so everything again outside of A. We're not touching A, we're not looking at A, forget about A. Alright? Alright, so let's talk about what intersection actually means. Alright, the intersection of two sets A and B is the elements that are both or common to both sets. Alright, so the notation for that would be that N, or like an upside down U, and this denotes the intersection of, right? So if a formal, I guess, set notation would be X is an element of A and B if and only if X is an element of A and X is an element of B. So let's look at an example right here. We have the set A is 1, 2, 3, 4, so I put that here. The set B is 1, 3, 5, 7, and I put that here. All right. The A intersect B is whatever they have in common, and so if I were to move these Venn diagrams together, all right, the only thing that they have in common is 1 and 3. So our A intersect B, the only things that are in A intersect B is 1, 3, and that's it. All right, and we can look at that and just see it from up here. This is in common and that is in common. All right, so that's the intersection. The intersection again is only the middle section right here. Whatever is in that middle section, that's what your answer is. All right. All right, so the second thing we're going to go over is the union. All right, the union of two sets A and B is a set of elements in A or in B or in both. All right, and A U U B, that's going to be our notation for union of. All right, so let's look at an example. We're looking at the same example, and this time we're going to look at the union of B. Right, before we saw that the intersection, right, is only the inside part, and we know now that that's 1, 3. A union B is everything that's in A, everything that's in B, and in both. So what we can write is all of the above. All right, so everything that's in A, everything that's in B, and everything that's in both, and that is the union. All right, so everything in these two circles is what we're going to write down. So the next part is the complement of a set. The complement of a set A is the elements that are not in the set A but are in the universal. All right, so this is read A dash, or I like to say A naught. All right, basically saying it's not A. All right, so let's look at an example. We have that the universal set is 1, 2, 3, all the way up to 10, right? X equals the set of the values X such that X is a prime number, right? So note that we don't need to say or specify that it's going to be less than or equal to 10 because well, the universal set is only up to 10 anyways. So if we're to write our numbers, A is this circle right here. This is going to be your union set. Let's write our numbers inside. The only thing that can go inside A is all the prime numbers. So 2, 3, 5, and 7. Everything else goes on the outside. All right, 8, 9, and 10. All right, so this right here is your universal set right here. A, again, is your prime numbers, right? So let's look at a couple of examples. I don't know why A naught is not in here, but A naught would be everything that's outside of A, right? So everything that's outside of A would be these numbers and these numbers. So we can write 1, 4, 6, 8, 9, and 10. All right. A intersect A naught. You can't do that because really nothing intersects here, so this is the null set, right? A union A naught, that means everything that's inside this circle, right, or inside this rectangle, and that's going to be the set, the universal set U. All right, you can write down all the numbers, but if you just write down the U, that tells us that we're looking at all the numbers in that set. All right. Alright, so one thing you guys need to practice is transferring the set of numbers into Venn diagrams, alright? So when you put these numbers in, only start in the middle area and then work your way out, alright? And then, again, don't forget the outside parts. So let's look at an example, alright? The universal set is the set of values of x such that x is less than or equal to 10 and x is an element of natural numbers, alright? So they're the natural numbers. If we were to write this out, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So that is the universal set. A, they're only prime numbers, right? So only prime numbers would be 2, 3, 5, and 7, right? B are only even numbers, and that would be 0, 2, 6, 9, or 6, 8, and 10. Sorry, 0 should not be in there. I'm going to cross this out. I don't know why I have that in there, but 0 should not be in there because a natural number does not go down to 0. Alright? Alright, so we're looking at these numbers. We want to fill in the middle first, and again, the middle is your A intersect B, right? So I'm going to put A intersect B. And that's only the things that are in common. So 2 is in common, and that's about it. So the only number that can go in here is 2. All right. Now for A, we're going to write the rest of the numbers. So 3, 5, and 7. For B, we're going to write the rest of these numbers: 4, 6, 8, and 10. All right. The outside numbers, it's whatever you did not use, right? So we use 2, we use 3, we use 4. We use 5, 6, 7, 8, and 10, right? Ooh. What's going on? And 10, right? So 9 and 1 we did not use, so we're going to put in 1 and 9. This is our set. So again, to recap, start in the middle, see what is in common with both of them. After that, whatever is left over, you're going to write in A. Whatever is left over in B, you're going to write in B. Whatever is left over in the universal, you're going to write on the outside, all right? So the next thing that we need to go over is the number of elements in two regions, all right? This is where we look at the cardinal number, and remember from last class, I told you to remember how to find the cardinal number, all right? You actually need to memorize this because I don't think this is on the formula sheet, and this is something you guys need to know in order to work out these Venn diagram problems, all right? So the first one is the cardinal number of A union B. To find that would be to take the cardinal number of A plus the cardinal number of B and then subtract it with the cardinal number of the intersection A and B. Alright? To find the intersection, basically we're just switching the union and the intersection around. Cardinal number of A intersect B is equal to cardinal number of A plus the cardinal number of B minus the cardinal number of A union B. Alright? Please write this down somewhere so you can basically, refer back to it. We're going to use this in the next couple of problems, all right? All right, so before we get into the cardinal number of each region, let's recap on how to write these elements into the Venn diagram, right? So we have A equals the set 1, 2, 3, 4, B equals the set 1, 3, 5, 7. Before we do, I said always start in the middle part right here, find that middle number, and that is A intersect B, right? And that is basically what A and B have in common. The only two numbers that are in common is 1 and 3, right? So we're going to put 1 and 3 here, and that transfers over here as 1 and 3. A union B would be basically everything in both the sets. So 1, 2, 3, 4, 5, and 7 will be in both A and B, right? But in order to write the A part right here, we only write what we didn't write, or we have left over. So 2 and 4 go here. What we have left over in B, 5 and 7 we put right here, right? So we're pretty much done. I just want to point out that these two are the intersections and these are the union, right? So right below I have this, right? So from the information given, we can basically count how many are in A, how many are in B, and now we can count how many are in A and B, and count how many are in A or B, right? So up here we have 4 numbers in A, so we're going to write down 4. We have 4 numbers in B, so we're going to write down 4. A and B, we have 2, so we're going to write down 2. And A and B is 1, 2, 3, 4, 5, and 6, so we're going to write down 6. Alright, so how does this translate to these right here? A intersect B, there's only 2 numbers there, so we're going to put a 2, right? And this is telling us how many numbers are in that set, right? A union B, there's 6 numbers in here, right? There's supposed to be 4 numbers right here, but we already used 2, so 4 minus 2, that gives you 2, so there's only going to be 2 right here, right? Same with B. B only has 4. 2 is already being used, so we have 2 left, and that's it, right? If we look, A union B, right, which is everything here, is supposed to equal 6, and if we add up 2 plus 2 plus 2, that also equals 6. Alright? So this is how you potentially do this. What I will give you are these type of numbers right here. You're going to have to fill it into the Venn diagram. Alright? Let's look at another example. Alright, so in this example, we're going to show, using the Venn diagram, how many elements belong to each region. Alright? So they give us this information right here. The cardinal number of the universal, which is 30, and we're going to just write that up here. So that means if we were to add up all the elements in here, it should equal 30. Alright, just take note. The cardinal number for A is 20, the cardinal number for B is 17, and the cardinal number for A intersect B is 12. So since they tell us this right here, we can write in 12 right here, right? We want to write these missing numbers or elements right here. Alright? For A, there's supposed to be 20, but we already used up 12, so that's left. 8 is left over. I don't know what just happened. Alright. So if we add or subtract those, we have 8 left over, so this is going to be 8. Alright. So for B, there's supposed to be 17. 12 is already used up. 17 minus 12 is 5, and so we're going to put 5 here. Right? If we add up all this, this is 25 right here, right? So we need 5 left over. And because we don't have anywhere else to put them, we're going to put the 5 in the universal set, the outside part, and 5 plus 8 plus 12 plus 5 is equal to 30. Alright? And this is how you start filling out these Venn diagrams, and later on it will get a little bit more complex, so please do the practices, alright? So this is the last example. I want you guys to write this down and write in the correct elements in each spot, alright? So you should have a number of elements here, 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 and here, and this should all equal 50. All right. So write this example down, bring it to class. We'll go over it, and then we'll go into more complicated problems like a 3 set. All right. All right, that's it.